Hello, my name is William Jackson Klein. I'm in section K-12 for Physics 2212, and this is Lab 3 Circuits. Some introductory information. The main ideas of this lab are circuits, specifically resistors and capacitors, and there are multiple purposes of this lab, including predicting the behavior of circuits containing resistors in series and parallel, using multimeters to measure the actual values of the conventional current and potential differences in the currents, and examine the behavior of ohmic resistors and capacitors. Some principles are the loop rule, stating that the potential difference between the start and end of a complete circuit is zero, and Ohm's law, stating that voltage equals current times resistance, and energy conservation. Brief overview of my results. I found that the resistance for the 47 ohm resistor was 48 ohms, and that the resistance for the 100 ohm resistor was 102 ohms, and that the resistance for the wires and the ammeters was zero. And I found an RC value of 5.995, which had an expected value of 6. Some notes and assumptions. The system is a circuit. Surroundings, anything that's not involved in the circuit. There's no real-life surroundings, though, since it was an online simulation. Initial conditions: set up the circuits as described in the lab. Make sure that you have the orientations correctly and that you have the correct voltages and resistances for the different parts. For the first one, we set up a circuit shown on our right here. And then for the second and third parts, the circuit involved a battery, capacitor, and light bulb. For the data, when the ammeters were inserted backwards, they were the same value, but theoretically it should be zero. When we broke the circuit and used the voltmeter to measure the voltage, we found that it had a potential difference of 3 volts, and that the ammeter read 0 volts because there was no current running through. Potential difference between A and B was 3 volts. Between C and D, it was negative 0.96, and between E and F, it was negative 2.04. And the difference between any other pair of neighboring points was 0, meaning that the sum of the potential differences around the circuit was 0, which was the expected value. The image to the right here is the graph between potential and position at different points. You can see from A to B, which is the 2 batteries, it goes from 0 to 3, stays 0 between B and C. From C to D, it drops by 0.96. From E to F, it drops by another 2.04, and then it ends at 0. Since the voltmeter doesn't provide any resistance or capacitance, the current doesn't change as long as the circuit's closed. When the ammeter was added in parallel, the current increases because the current then flows through the ammeter with no resistance rather than through the resistor. And as I mentioned earlier, the resistance of the 47 ohm resistor was 48. For the 100 ohm resistor, it was 102, and it was 0 for anything else. When the light bulb was connected between the battery and the capacitor, it started out bright, but then it discharged slowly as charges built to the capacitor, and acted the same way as the capacitor was discharging. This is because it charges and discharges exponentially, meaning that it's not at a constant rate, and the current reduces as the capacitor is charging or discharging. The charging time for the 10 ohm light bulb was 15 seconds. Discharge time was 20 seconds. For the 20 ohm light bulb, it was 30 seconds to charge and 40 seconds to discharge. Here is my natural log of voltage versus initial voltage versus time graph. The table right there shows the data, with the first column being time and the last column being the natural log of voltage over initial voltage, and the graph over there shows the line of best fit. We had a slope of negative 0.1668, which is supposed to be equal to negative 1 over RC, meaning that we got an RC value of 5.995. The expected value is 6, so we did not have very much error there, and we were very close. Additional questions: there aren't many differences between our experiment and the model because this is basically a model. Some potential sources of error are human error, mostly while timing, although there could be some for setup for the circuit, or just like blatant disregard of instructions, or a bug in the computer simulation. If this were a real-life lab, the ammeter reading would be less than it was in the simulation, because in real life, ammeters do provide some resistance, even though it might not be much. There is still some present, so it would take effect. And if we were using a real battery to charge a capacitor, theoretically, it would charge instantaneously. However, this can't happen. There will still be some short period of time where the charges will build up on the capacitor. in conclusion, this lab did give me a better understanding of circuits and how resistors and capacitors function. It's not completely representative of real life, but it did give me a better understanding of what should happen theoretically. I really did enjoy this lab. I think it improved my understanding significantly, and I'm glad I got to participate in it. Thank you so much, and I hope you have a great day.